lecture here on ratio schedules, but before we actually get into it, midterm exam scores will be entered later today, so you can take a peek at Blackboard and look how you performed on that. And we're going to play with the actual exam itself. I am going to make some decisions on it. And you'll see that reflected on the scores on the Blackboard. So let's talk about Lesson 12, Schedules of Reinforcement, and we're going to talk about ratio schedules. The first place to start is to talk about Skinner's research and his book, Schedules of Reinforcement, published in 1938. That was a monumental scientific effort and publication. What he demonstrated in that 1938 book, Schedules of Reinforcement, was that the behavior of organisms is consistently regulated by a schedule of reinforcement. In other words, when that reinforcer is presented, whether it be after a period of time or after a number of responses, consistently demonstrated that our behavior is influenced by a schedule of reinforcement. So that's what these next two lessons are about. So let's talk about first what a schedule is. Okay? A schedule is the way in which the reinforcer is presented due to the number of responses, the passage of time, or the stimulus conditions. That's a schedule. Okay? So, we're going to talk about three big categories of schedules, and then we'll talk about two types of schedules within a category. Alrighty? Continuous reinforcement schedule. This means that the desired behavior is reinforced every time it occurs. A continuous reinforcement schedule. The desired behavior is reinforced every time that it occurs. Now, when we say desired, we simply mean that's the behavior we want to reinforce. Okay? Then we have an intermittent schedule. The word intermittent means periodic, every now and then. It's not like your windshield wiper control in your car. They call those intermittent wipers. But it's really not intermittent. Those wipers, when you flip that switch to so-called intermittent, they wipe after a fixed number of seconds. That's not what intermittent means. Intermittent means every now and then, in our term and our analysis of schedules of reinforcement. So we are going to periodically reinforce a behavior, an intermittent schedule. And then Miller talks about an extinction schedule. We know what that is. We covered it already. That means that the behavior occurs and there is no reinforcer being presented anymore. An extinction schedule. Response-based schedules. This is where the reinforcer is presented depending on the number of responses that are required to fulfill the schedule. It's a response-based schedule. In order to earn the reinforcer, you must make a response or a certain number of responses. Response-based. We're going to start out with a fixed ratio schedule of reinforcement. With a fixed ratio schedule of reinforcement, the reinforcer is delivered after a fixed number of responses. We've got an example here with our funky vending machine on the 3rd floor. The button for your favorite snack requires that you push it 2 times before it delivers the food at the bottom of the vending machine. If you press it once, you get nothing. You must press the button 2 times to get your food. That's a fixed ratio 2 schedule of reinforcement. 2 responses are required before the reinforcer is presented. Fixed ratio. So, let's look at what the letters and numbers mean, how to interpret those. The F in a fixed ratio schedule. The F means fixed. And one definition of fixed is never changing. That's our definition. You see the letter F, it means never changing. It is fixed. The R, ratio, indicates this is a response-dependent schedule. There's a certain number of responses that must be emitted before the reinforcer is presented. Then the R is followed by a number. In this case, we have a 6. This is telling you that 6 responses are required to fulfill the schedule requirement. So it is an FR6 schedule. Okay? F means fixed, R is the ratio requirement that needs to be fulfilled, and the number tells you how many responses must be performed before the reinforcer is presented. So we got another example, FR8. How many responses must be emitted? 8. When will the reinforcer be presented? After the 8th response. What happens after the 6th response? Nothing. Nothing. What happens after the 2nd response? More nothing. Okay, so our little animal presses the lever 8 times, immediately reinforced by the presentation of food. A little bit of a break, it's called a pause, and then that animal starts to respond again. When will the next reinforcer be presented? Pardon? After 8 responses. Exactly. It's a fixed ratio 8. No reinforcer until that 8th response is presented, or occurs rather, excuse me. Likewise with an FR28, when will the reinforcer be presented? After the 28th response. No reinforcer between 1 and 27. Only after the 28th response. And then we start all over again. The next reinforcer occurs after the 28th response. Now, schedules produce what's called a pattern of responding, or a response pattern, either way. Okay? Now, with a fixed ratio schedule, there is a distinct pattern that you can observe. It's a high rate of responding until the schedule requirement is met. Then there's a pause where no responding occurs. And then when the animal, the human being, starts to respond again, it's at a high, steady rate until the ratio requirement is met, followed by a pause. Yes?
Why is there a pause?
The pause occurs because of the amount of effort that goes into earning the reinforcer. Okay? What's really interesting is, let's say we have a FR2, fixed ratio 2 schedule. When will the first reinforcer be presented? After the second response. And then there's a tiny little pause. Not much effort, right? 2 responses, immediate reinforcement, little break, smoke a cigarette, drink some beer, and then you start again until you meet the schedule requirement. Now, if you have to engage in more effort, let's go from a FR2 to a FR20. That's 10 times as much, right? So you're starting to respond. You continue to respond until you get the reinforcer. That's a lot of effort. 10 times as much. Are you going to take a little break or a longer break? A longer break. So now the pause in responding is proportional to the amount of work that you have to do, which is really fascinating. So we work and then we pause. We work and then we pause. So, FR pattern. If we looked at it on a cumulative strip chart, cumulative recorder, it would look like a staircase. Okay? This is our picture of an FR schedule based on a cumulative record. This is used to call them a strip chart, a piece of paper with ink pens scribbling along, and each time the rat pressed the lever, the pen would click up, mark more ink going this way, and then it would reset and keep doing the same thing. Okay? So this is kind of difficult to see, but here's our rat responding at a high, steady rate. There's the reinforcer, that hatch mark, and there's our pause. And then once responding starts again, it just continues until the ratio requirement is met. And then we have a pause. And it looks like a staircase, right? That's what you see with a ratio schedule. It's really quite amazing. So, to say it again, we get a high, steady rate of responding, followed by a pause after the reinforcer's been presented. And then we start again with a high, steady rate of responding until the reinforcer is presented once again. That's our response pattern. Variable ratio schedule. Now this is just a variation on a fixed ratio or response-dependent schedule. Variable in this context means changing. So we have a variable ratio schedule where a behavior is going to be reinforced after a varying number of responses has occurred since the last reinforcer. Varying meaning changing. So the reinforcer is going to be presented after a varying number of responses since the last reinforcer. Okay? So let's consider, these are called ratio runs. And a ratio run simply means how many responses are required before the reinforcer is presented. On an FR schedule, it's always the same number, right? The ratio run is 8 or 2, whatever the ratio requirement is. But on a variable ratio schedule, that ratio run is different each time. So let's say it's a 5 for the first ratio run, and after 5 responses, we've got the presentation of a reinforcer. The counter resets. The next ratio run is 8. Now we must have 8 responses before the reinforcer is presented. Counter resets to 0. And now the next ratio run is 15. Now we need 15 responses before the behavior is going to be reinforced. And now we have a variable ratio schedule of reinforcement. Went from 5 to 8 to 15. And it's going to continue to vary. The number of responses required for each ratio run will change since the last reinforcer. There was the last reinforcer, it changed here. This was the last reinforcer, we went to here, and then we have another ratio run. It might be 3. So it's constantly changing. So if we did a little math, are you ready to do a little math? Anybody have a calculator? You guys do, I don't know. Okay, let's do the math. 5 plus 8 is 13, plus 15 is 28, plus 3 is 31. Divide by 4 is 7-ish, isn't it?
7 point something.
So we've got, just looking at these examples, we have a VR 7.
7.75.
Very nice. We're going to stay with 7. Okay? Variable ratio 7. So this means that the reinforcer is being presented on an average of after every 7th response. Okay? Variable ratio. V tells us it's a variable schedule. R tells us it's a ratio schedule. There's a response requirement that must be met. 7 tells us on the average, every 7th response will be reinforced. VR. We got a couple examples here. VR8, it's going to be reinforced on the average after the 8th response, 28, and so on. Just like what we covered previously. This is an example of a variable ratio response pattern from a cumulative recorder. That's pretty impressive. Do you see any pauses? No. Now what I do want you to notice is, here's the rat responding. That red horizontal line indicates the presentation of the reinforcer. The ratio run was completed. Now let's look at just simply the distance from here to there versus there to there. Which one is bigger? The first one, which means the ratio run here was of much greater requirement than here. And what about comparing this ratio run to that one? Bigger or smaller? This one's bigger than that one, so this ratio run was smaller, right? and this one is about the same. This one gets smaller, then it gets real small. So it's constantly changing after each reinforcer. A high steady rate of responding, no pauses on a variable ratio schedule. If we looked at the pattern of responding on an FR schedule and a VR schedule, if we just eyeball it, it sort of looks like they produce the same rate of responding. And when I say rate, that's number of responses per minute. Except what happens on an FR schedule? We have a pause. That's when you're smoking cigarettes and drinking beer. You're doing nothing, right? So when we average in the pauses, a VR schedule produces much more responding than an FR. Because there are no pauses. We'll go back and just check it out. There are no pauses there. So if you want your child, your dog, your husband, your wife, whatever, to work hard without pauses, this is the schedule. Variable ratio. This is the best way to get productivity. An important concept is one called resistance to extinction. Now we know what extinction is. That's when we stop the reinforcer for a previously reinforced behavior and the frequency of responding decreases to 0. And we say that the behavior is extinguished. Resistance to extinction is how long does that behavior persist? How many times does the organism continue to respond during extinction? If responding continues for a long time during extinction, we describe that as the behavior being very resistant to extinction. If the behavior goes immediately to 0 during extinction, after being on a particular schedule of reinforcement, we'd say the behavior was very influenced by the schedule and not resistant to extinction. So, schedules of reinforcement really influence a person's and organism's resistance to extinction. Continuous reinforcement schedules. If your behavior is reinforced every time it occurs, it's not going to be resistant to extinction. That behavior will cease to occur almost immediately. On fixed ratio schedules, the behavior on that schedule of reinforcement will be a little bit more resistant to extinction. But when we compare the behavior on a VR schedule to the previous two, behavior that's been on a variable ratio schedule of reinforcement and then is put on an extinction schedule is highly resistant. Because you can't predict when the reinforcer's coming. You can't tell the difference. Is this a reinforcement contingency? Is this an extinction contingency? Because the number of responses required is always changing. You cannot tell the difference. In other words, you cannot discriminate the reinforcement contingency from the extinction contingency if you've been on a VR schedule in the past. Question?
So in order for them to not extinguish the behavior, would they have to know in advance that they're going to get reinforcement? Just not know when, or?
I'm not quite sure I understand. So I think this is what you're saying. If we want a behavior to persist, what schedule would we use and how would we use it when we go from the reinforcement to the extinction condition? Is that what you're saying?
Yeah, I'm mostly just thinking about how typically extinction actually keeps the behavior from happening, and that if they don't know that they're going to get a reinforcer, they might stop doing the behavior.
Well, that's extinction.
Right.
Yeah, that's extinction. So you're responding, and that behavior has been intermittently reinforced. That's what a VR schedule is. It's periodic reinforcement based on the number of responses. So you can't predict when the reinforcer will occur, and you can't predict how many responses are required to produce the reinforcer. And then you go into extinction. Okay? And maybe this will help again. Let's back up. There's our VR pattern of responding. This little organism, human, pigeon, or rat, cannot discriminate how many responses are necessary before the reinforcer. And then it changes. The response requirement, oddly enough, is smaller. But there's no signal. There's no information. You just keep responding. And there's the reinforcer, and oddly enough, fewer responses are required here. And curiously, it gets that way throughout the entire pattern here, in this example. Okay? So, if we go from a reinforcement condition like this to extinction, there will be no signal. There will be no information to the organism saying, okay, my behavior's on extinction, I'll just stop now. And there's no information telling the organism, okay, if I keep responding, that behavior will be reinforced. Because look at how many responses had to occur here. Quite a few. And because we've got quite a few less, and so on and so forth, it becomes unpredictable. And that's why that person, that organism with a history of a VR schedule, will persist in their responding. Here's an example that's similar to what we're talking about. People who gamble. Anybody go to the boats? Okay, Cody's wealthy from going to the boats. The slot machine. You can play quarter slots, penny slots, dollar slots, what have you. Can you predict when you're going to win? Why do you keep pulling the lever then? Because you might. But you can't predict it, right? You pull it once, whoa, you get all this stuff in the trough down at the bottom. Or you pull it 20 times. And on the 21st pull, you get a few, right? That's a variable ratio schedule. It's just like our little rat pressing the lever, except you're pulling the lever. Okay? Gambling casinos are using a variable ratio schedule of reinforcement to keep you responding at a high, steady rate without pauses. Have you heard stories? Maybe this story is of you. People sitting, pulling that lever 8 hours? That's nuts. Question? Or you heard the story?
I actually worked at a casino.
Oh, you've got horror stories. Okay? Any questions before I press the button again? FR, VR, pattern of response, and resistance to extinction. Okay? Cool stuff. You can get high rates of responding without giving any more reinforcer. Remember the lesson on reinforcer effectiveness, bigger is better. We don't need to do that. We can get high rates of responding giving a teeny, teeny, tiny amount. And that person at the casino will still pull that lever. That pigeon will still peck the disc. They're not getting any more after 125 pecks. They're getting the same amount of the reinforcer. The little rat who presses the bar for 150 times and gets a few grains of food. It's the same amount of the reinforcer, whether it be 25 lever presses or 125. That's pretty interesting. Because we're giving small amounts with a high response requirement, we don't have the problem of satiation, where you have too much of a good thing, which is rare in life. Problems with ratio schedules, this thing called ratio strain. Ratio strain. That's where the behavior is disrupted. Performance breaks down because the ratio requirement is too great before the reinforcer is presented, or the change in the ratio requirement was too abrupt. It was too big. Okay? So let's look at our example here. If we had a rat on a FR schedule 2, every 2 responses would be reinforced. And we go, yeah, our little rat's doing great, so let's jack it up to an FR 25. That little rat would press the lever a couple times, have a pause, a couple times, have a pause, maybe a couple more times, and then nothing. Because the change in the response requirement was too great. Ratio strain. And the behavior is on extinction during that long period of time during which they have to respond and get nothing. Okay? Ratio strain. A real life example, graduate students who have to do a thesis as part of their master's research. They go through all of the master's level classes, they're doing fine, and now they have to do an independent research project, which requires a lot of behavior, a lot of responses. It's not like reading a book chapter and taking an exam. And many, many, many graduate students stop responding once they hit that level called thesis research. The response requirement is just too great for them. And they don't respond. They drop out and they don't get their graduate degree. Very common. Okay. I think that's it. Yep. This will be uploaded into our YouTube channel. I urge you to A, watch it. B, be sure you review your